In the previous episodes, we already covered the VAE, the diffuser, and the latent space, but there is one giant problem. AI doesn't understand human language at all. If you type in "a cat in a hat" to the AI, it's just a meaningless sequence of letters. This is where the text encoder comes in, the bridge between you and the AI's inner world. Imagine traveling to a foreign country where you want to hire a brilliant local artist to paint a picture for you, but you don't share a single word of a common language. You need a translator. You tell the translator in your own language what you want to see, and they translate it for the artist into a language that tells the painter exactly what to put on the canvas. The text encoder is exactly this brilliant translator. When you type in your prompt, the text encoder instantly analyzes the words and transforms them into a sequence of numbers. This is what we call a text embedding, which is mathematically a vector. But what do these numbers actually mean? Here is the genius part. These numbers are the exact coordinates of the same multidimensional latent space we talked about in the previous video. The AI's entire inner knowledge, its so-called weights, is mapped out as numbers in this exact same space. When the text encoder generates the numbers for your prompt, the AI takes this vector and starts comparing it to its own internal weights. It checks which of its internal concepts, or weights, are closest to your numbers. This way, the diffuser knows precisely which spot in the latent space to walk into and what to carve out of that digital noise. In essence, without the text encoder, modern generators like Flux 2, Midjourney, or Z-Image would be completely deaf to our requests. It is the tool that translates your words into the language of the AI's internal weights. In the next episode, we're stepping it up a notch to look at those mysterious abbreviations you see every time you download a model. What exactly are FP32, FP16, and FP8? Follow the channel so you don't miss it.